All right, solving systems of inequalities. Now we aren't going to get an x and a y. We're going to have to be very neat. We have to graph it, so this is a graphing method. So we're going to need to remember our y equals mx plus b, our slope-intercept form. Okay, now the difference here is it's inequality, which means it's not going to be equal. So let's do a simple example. Let's do y is less than x, and let's do y is greater than 1/2 x minus 3, or minus 5. So when I'm solving a system of inequalities, I am going to graph them. So the first one, what's our y-intercept for y is less than x?
No, 0.
Yep, the y-intercept is 0. And what's our slope? 1. Okay, so I'm going to start as 0, and I'm going to go up 1, right 1. Now the thing with this, though, is this line is actually going to be a dotted line. It's not going to be a solid line, and I'll explain how I know that in a minute. But this is a dotted line. Alright, now I'm going to go and graph the other line. I'll go ahead and graph that one in green. My y-intercept's -5. So this is a good review for your quiz tomorrow. This isn't on your quiz, but you do have to graph on your quiz, so, you know, good review. And then I go up 1, right 2. And this line is also dotted. Now they would eventually meet somewhere, but in the case of inequalities, I actually don't care where they meet so much. Okay. I want you, regardless whether you actually have this graphed or not, I want you to look up to make sure that you are seeing what I'm talking about. When I see this symbol, I need to remember that it means less than, as I read left to right. And when I see this other symbol, I need to remember, oh, my thing's all going wonky. When I see this symbol, I need to remember that symbol means greater than. So, when I look at this less than, is being equal an option?
No.
No. It has to be less. That's why the line is dotted. Okay? Same for the greater than. This greater than, is being equal an option? No. That's why the line is dotted. But then there's something else I need to do. Anything that's smaller is going to work. Okay? So, I look at this line, and I want values that are smaller than this line. You with me?
Yeah.
Well, smaller would be below the line. So lightly, with my pencil, I would shade, and I can't shade too well on this thing, but I would shade everything below my first line. Notice that that ends up including the green line. Now let's look at the green line. Look. Greater. Well, that's going to mean everything that's bigger than that line. Okay, so I look at this line, and things that are bigger than this line would be above it. So I lightly, with my pencil, I shade above that line. And notice something has happened. The two areas that I've shaded now overlap. Now, they don't have to overlap. If they don't overlap, that's no solution. But notice in this case, they do. So what's my answer? Well, everything that's in between these two lines ends up being my answer. Okay? I'll give you a moment to go ahead and graph that. Now, don't scribble like I did. I have no choice on this but to scribble. Okay? But you need to make sure you make clear what your answer is. What I would do if I were you is I'd lightly shade the two lines and then darkly shade where your answer is with your pencil. So it's basically, welcome to color. You had no idea in kindergarten when you were learning to color, you're actually doing math class.
Why are you shading?
Yeah, why are you shading here?
That's the answer.
No, but like, how do you get?
Okay, get the graphs down, and then I'll re-describe, perhaps with some different words. Let's go back and build this case. If I did x is less than -3, this will be good for your midterm review. And I told you we'll graph that. Well, this is in one dimension. Well, how do I know? There's only in x, right? There's not two variables. So I do a number line, right? And we would do -3, -2, -1, 0, 1, 2, right? And then, what did I tell you? Open circle, right? Why? Because I can't be equal. In which way would I go?
Left.
To the left, because all of these are negative. That means the following would be answers: -4, -5, -6, -4.1, -100.3 repeated. All of those are answers. Why? Because they're all less than -3. But now I'm in two dimensions. So if I had x plus y is greater than 2. I'm in two dimensions now, which means I need an xy graph, right? xy, so xy. And right here, I would need to solve for y first, so I subtract my x. My y-intercept is 2. And then this slope means go down 1, right 1. So, well, why then do I do this shading? Well, I'm trying to find a way to represent, like up here I did a line, right? And that was pretty easy because it represents all the things that are less than 3. I need to represent all the xy combinations that are greater than 2. So, that's going to be, in this case, above the line. Now, do you see why that's above the line? I look at a point, I look at this point, and I'm like, well, up here is above and down here is below. Does that make sense? How I get above and below the line?
So,
All right.
So if it's just got 1 and it's one dimensional, you only have to do the number 1.
Now, we could put this on a two-dimensional graph. And actually, we are going to do that in a few moments. But, yeah, if you're in one dimension, you only need one dimension.
Wait, so I'm still confused on how you know their shape.
Okay. This symbol means bigger. Okay, so this is a line. So I want all the points that are bigger than the line. So if I look at this point right here, and I think, well, what is bigger than that point? This point, this point, this point, this point. I look at this point and I want, see, greater than. Well, what's bigger than that point? This point, this point, this point. So I shade above this line because all those points are bigger than the y values of this line. Now, there is a way to do it. Other teachers would say use 0, 0 as a test point. And meaning you put 0, 0 in here, and if it works, if it's true, then you shade where 0, 0 is. And if it doesn't work, then you shade where 0, 0 is not. I just think it's easier to think above or below. But that's Kane thinking, so, you know. Let's go ahead and take a look at this system. Okay, so we are going to graph this system. And how do I know I need to graph it versus doing elimination? Well, it's not equal. So I can't do an algebraic method. So the first thing I need to do is solve for y. So I can get it into slope-intercept form. Okay, so I'm going to solve this first equation for y. So I'll subtract the 2x. And then I'm going to divide by -3. Who remembers something that we need to do when we divide by a negative?
You have to switch the signs.
Yeah, I need to switch the inequality. So when divide or multiply by a negative, flip the inequality. symbol. Just the symbol, not the whole thing, just the symbol. So I'm going to divide by -3, everything. And I get y is less than or equal to x minus 2. Any questions how I got that? Okay, so I'm going to graph that one.
Well, wouldn't it be 2/3?
Yes, I'm stupid. 2/3. Good job, Ryan. Keep me honest over here. Never know when I'm going to be a bonobo.
Yeah.
Okay, let's try -5x plus 2y is less than 10.
No, I'm trying to check. Oh, you want to know that part? You know that part.
Do you want to check these? So like if I want that one. See how I did that? If I want to do that one. See how I do that? Okay, check it yourself. All right, so we're going to add the 5x. And then what? Divide by 2. Yes. And then we are going to graph both these lines. Now this line right here is not dotted. Why? Because I can be equal. And this line is dotted because I cannot be equal. Alright, so I have those written down so that when I go over to this graph, erase all this sloppiness. Alright, so what is our first line? Y is what?
-2. Oh, no. 2/3.
2/3.
Correct.
Trey. X
-2.
minus 2. So I start at y equals -2, and then I go up to right 3. And this line, dotted or solid? Yes, solid.
How do you know? I'm sorry. Oh,
Because it should be equal to. So this is a solid line. And now do I shade above or below this line?
Below.
Below because it's less. So I just lightly with my pencil do this. That's below that line. Now I graph the next line. I'll do that one in blue. And the next line was y is less than. Is it less than?
2. Yeah.
5 over 2 x
Wait. Yeah.
plus 5. Yes. Okay. So 1, 2, 3, 4, 5. So up 5, right 2 is way up there somewhere. So I'll reverse this. And then this line is dotted. How do I know that it's dotted?
Because it's not like a or greater than or something.
Yeah. And I shade above or below?
Below.
Below this line. Well, this line's getting pretty steep here, right? But do you see, like, look how I figured this out. So I look at this point right here. And I think, well, what's below that point? This point, this point, this point. Do you see what I mean? Okay. So there's my shading. And then where's my answer? Where they overlap. So I would darken this area right here. Don't just scribble it. I darkened that area right there. And that's my answer, because that's below both the lines. Now we could have a case where there's no solution. So we're going to do a no solution one right now. But we still do all the steps that we just did. You just don't darken any particular area. Okay. And I'll just stay on this slide right here. Do we see what we did? Okay. Let's say I want y is greater than 2x plus 3. And let's say y is less than or equal to 2x minus 1. And that's my system. Now it's already in slope-intercept form. So the first line, I start at 3. And I do what?
go up to.
Up to and right 1. And is that going to be dotted or solid?
Dotted.
is going to be a dotted line. And do I shade above or below that line?
Above.
Above. So this is my shading. How about the second line? Where do I start?
-1.
At y equals -1, and then I go up to right 1. Is this going to be dotted or solid?
Solid.
Done.
It's loud.
It's solid.
Really?
Oh. Okay, and do I shade above or below that
Under
line?
it. Under it.
Below.
Below. And do they overlap anywhere?
Nope, it's a no solution.
No solution. Okay, so no solution to that one. Any questions on this?
Wait, what was the other one? What was the answer to the other one?
Is wherever you darken.
Ah, okay.
Wait, so how do you know
Okay,
if
you
you
got-
go over?
Huh?
How do you know if you go shade above or below?
Okay, so this symbol is greater, which means bigger, which means above. And this symbol is less, so smaller, so that means below. All right, so let's do a table of that. Less than, greater than, less than equal, greater than equal. So less than, we are dotted, and we are below the line. Or left. I'll show you that in a moment. Greater than is dotted, and this is above the line, and this is to the right. I'll show you that in a moment. This is a special case that I'm putting here at the right, so mostly think above and below. Less than or equal to, that's going to be solid, because we can't be equal, and we're going to be below the line. And greater than equal, that is also solid. Okay, but this is going to be above the line. All right, so what are we going to do for the special case? I want to show you the special case. Never mind, I'll show you tomorrow.
Yes, no,